Alright, so what's up guys? Infinity here. Today, we're taking a look at something that's not just a futuristic dream, but is actively being engineered and implemented right now, the evolution of our urban environments. Welcome to our deep dive into the innovative technologies that are shaping the cities of tomorrow. From smart infrastructure, the very backbone of these new urban landscapes, to the intricate workings of AI-driven urban planning. Let's explore how these advancements are transforming urban living, making our cities more responsive, efficient, and hopefully more livable for everyone. This isn't just about adding a few solar panels or some self-driving cars. It's a fundamental rethinking of how cities operate. We're talking about a complex interplay of interconnected systems, all designed to optimize resources, enhance sustainability, and improve the quality of life for billions of people. Think of it as upgrading the entire operating system of a city. The scale is massive, the challenges are significant, but the potential benefits are truly transformative. We'll be breaking down some of the key technologies driving this change, looking at what they are, how they work, and the impact they're starting to have. So we're going to explore everything from how your city might manage its energy grid more intelligently, to how it keeps traffic flowing, and even how it grows food in new and innovative ways. It's a journey into a future that's rapidly becoming our present. We'll look at the hardware, the software, and the big ideas that are converging to create these next-generation urban spaces. It's a lot to cover, so let's get straight into it. Alright, so kicking things off, let's dive into smart infrastructure and the Internet of Things, or IoT. This is, without a doubt, the foundational layer, the very nervous system of any truly smart city. Imagine an urban environment where almost every critical piece of infrastructure is no longer just a static object, but an active, data-collecting node in a vast network. We're talking about streetlights that do more than just illuminate, bridges that report their own structural integrity, and waste bins that signal when they're full. It's about embedding intelligence directly into the concrete and steel that makes up our cities. These interconnected devices, packed with sensors, are constantly gathering and transmitting data in real time. This creates an unprecedented level of awareness for city planners and operators. Think about predictive maintenance. Instead of waiting for a water pipe to burst or a bridge to show visible signs of decay, sensors can detect subtle changes, anomalies, or stress patterns, allowing for proactive repairs. This not only saves money by addressing issues before they become major problems, but also enhances public safety by preventing catastrophic failures. It's a shift from reactive to predictive management, which is a huge deal. Then there's the efficiency aspect, particularly with energy use. Smart streetlights, for example, can dim when there's no pedestrian or vehicular traffic, or adjust their brightness based on ambient light conditions. This might seem like a small thing on an individual level, but when you scale it across an entire city with tens of thousands or even hundreds of thousands of lights, the energy savings become substantial. This same principle applies to building management systems, public water systems, and traffic control, all optimized through real-time data and intelligent automation. The IoT infrastructure also enables a more responsive city. For instance, in an emergency, connected traffic signals could automatically create clear routes for first responders. Public transit systems can provide incredibly accurate real-time arrival information, not just based on schedules, but on the actual location and speed of vehicles. This level of dynamic response makes the city feel more alive and adaptive to the needs of its inhabitants. It's about making urban services more reliable and user-friendly through a constant flow of information. Of course, deploying and managing such a vast network of sensors and connected devices comes with its own set of challenges. There are concerns around data security, privacy, the cost of implementation, and ensuring interoperability between different systems and vendors. These are not trivial issues and require careful planning and robust cybersecurity measures. However, the sheer potential for creating more efficient, resilient, and livable urban environments is driving cities worldwide to invest heavily in these foundational IoT technologies. Ultimately, smart infrastructure powered by IoT is about creating a digital twin of the city, a dynamic model that reflects its current state and helps predict its future needs. This data-rich environment empowers decision-makers with the insights needed to optimize resource allocation, improve services, and build more sustainable communities. It's the invisible intelligence that will underpin so many of the other innovations we're going to talk about today, making it a critical starting point for any discussion on future cities. All right, next up, let's talk about something absolutely critical for sustainable urban living renewable energy integration. As cities continue to grow, so does their energy demand. The traditional model of relying heavily on fossil fuels is simply not sustainable in the long run, both environmentally and economically. So future cities are increasingly looking to harness the power of renewables, integrating them directly into the urban fabric. This isn't just about large-scale solar or wind farms located miles away. It's about bringing clean energy generation closer to where it's consumed. We're seeing a significant push towards deploying solar panels on a massive scale, not just on residential rooftops, but also on commercial buildings, carports, and even integrated into building facades as photovoltaic glass. Think about vast expanses of otherwise unused surface area now contributing to the city's power grid. Alongside solar, urban wind turbines, though sometimes more challenging to implement due to space and aesthetics, are also finding their place, especially smaller, more efficient designs suited for built-up environments. The goal is to diversify the energy mix and reduce reliance on centralized, carbon-intensive power plants. Beyond generation, energy storage is a key piece of this puzzle. Renewables like solar and wind are inherently intermittent. The sun doesn't always shine, and the wind doesn't always blow. This is where advanced battery storage systems come into play. These can range from large, utility-scale batteries that help stabilize the grid, to smaller, localized storage in buildings or community microgrids. These systems store excess energy generated during peak production times and release it when demand is high or generation is low, ensuring a more reliable and consistent power supply from clean sources. The integration of these renewable energy systems with smart grid technology is also crucial. A smart grid can intelligently manage the flow of electricity, balancing supply and demand in real time. It can, for example, prioritize the use of locally generated renewable energy, or even allow buildings with their own solar and storage to sell excess power back to the grid. This creates a more dynamic, decentralized and resilient energy infrastructure, far removed from the old one-way flow of power from large plants to consumers. Public transportation is another area ripe for renewable energy integration. Electric buses, trams and trains powered by renewable sources are becoming increasingly common. Charging infrastructure for electric vehicles, ideally powered by solar or other renewables, is also expanding. This not only reduces direct emissions from the transport sector, a major contributor to urban air pollution, but also lessens the overall carbon footprint of the city's mobility systems. It's a holistic approach to decarbonizing urban life. The journey towards fully renewable powered cities is a long one, with hurdles like upfront investment costs, the need for grid modernization, and policy frameworks that support distributed generation. However, the declining costs of renewable technologies, coupled with growing awareness of climate change impacts, are accelerating this transition. Cities are recognizing that investing in renewable energy isn't just an environmental imperative, but also an economic opportunity, creating green jobs and fostering innovation in clean tech. All right, so let's shift gears and talk about autonomous transportation. This is one of those technologies that often feels like it's perpetually just around the corner, but the progress being made is undeniable, and its potential to reshape urban mobility is immense. We're not just talking about self-driving cars for individual use, though that's a big part of it. Think broader autonomous buses, delivery drones, robotic shuttles, all working to make getting around and receiving goods in a city more efficient, safer, and potentially more equitable. One of the biggest promises of autonomous vehicles, AVs, is the potential to significantly reduce traffic congestion. AVs can communicate with each other and with smart traffic infrastructure, allowing for optimized routing, smoother traffic flow, and reduced phantom traffic jams caused by human driving habits like sudden braking. They can also drive closer together more safely, increasing roadway capacity. Imagine a future where your commute is not only hands-free but also faster and less frustrating, simply because the vehicles themselves are coordinating their movements. Safety is another huge driver for autonomous transportation. A vast majority of traffic accidents are caused by human error. Distraction, fatigue, impairment, AVs, equipped with an array of sensors like LiDAR, radar and cameras, and powered by sophisticated AI, have the potential to be far more vigilant and quicker to react than human drivers. While the technology is still being perfected and rigorously tested, the long-term vision is a dramatic reduction in road accidents, injuries and fatalities. This would be a monumental achievement for public health and safety in urban areas. Then there's the impact on urban design and land use. Currently, a significant amount of urban real estate is dedicated to parking. If autonomous vehicles can operate as shared fleets, picking up and dropping off passengers as needed, the demand for individual car ownership and consequently parking spaces could decrease substantially. This could free up valuable urban land for other uses like green spaces, housing or pedestrian zones, making cities more people-centric rather than car-centric. It's a fundamental shift in how we think about personal mobility. Autonomous public transportation also holds great promise. Self-driving buses or shuttles could offer more flexible and on-demand services, potentially extending public transit coverage to underserved areas or operating more frequently during off-peak hours. This could make public transport a more attractive option for more people, further reducing reliance on private cars. For logistics, autonomous delivery drones and ground-based robots could handle last-mile deliveries, reducing delivery truck traffic and speeding up the movement of goods within the city. Of course, the path to widespread autonomous transportation is paved with challenges. There are complex regulatory hurdles to navigate, public acceptance to build, and significant ethical considerations, particularly around accident liability and decision-making in unavoidable crash scenarios. Cybersecurity for AVs is also paramount to prevent malicious attacks, and the infrastructure needs to be ready, potentially requiring upgrades to roads and communication networks to support vehicle-to-everything (V2X) communication. Despite these hurdles, the development in autonomous transportation is relentless. Companies are investing billions and pilot programs are expanding in cities around the world. The potential benefits: increased safety, reduced congestion, lower emissions, especially if AVs are electric, and improved accessibility for an aging population or those with disabilities are too significant to ignore. Chapter 4. Green Building Technologies, Sustainable Structures. So, let's move on to the buildings themselves, because the structures we live and work in are massive consumers of energy and resources. Green building technologies are all about minimizing this impact, making our buildings more energy efficient, healthier for occupants, and better integrated with the urban environment. This isn't just about slapping some solar panels on the roof. It's a holistic approach to design, construction, and operation that prioritizes sustainability at every stage. One of the core pillars of green building is the use of advanced, sustainable materials. This includes recycled content materials, sustainably harvested wood, low VOC, volatile organic compound, paints and finishes that improve indoor air quality, and innovative materials like self-healing concrete or super-insulating aerogels. The choice of materials can significantly reduce a building's embodied energy, the energy consumed in extracting, processing, manufacturing, and transporting those materials, as well as its operational energy needs over its lifespan. Then there are smart HVAC, heating, ventilation, and air conditioning systems, which are a game changer for energy efficiency. Traditional HVAC systems are often oversized and operate on simple on-off cycles. Smart HVAC systems, however, use sensors, AI, and predictive analytics to optimize heating and cooling. They can learn occupancy patterns, adjust to real-time weather conditions, and even identify areas within a building that need more or less conditioning. This precise control can lead to substantial energy savings, often 20 to 30% or even more, while maintaining or improving occupant comfort. Water efficiency is another key aspect. Green buildings incorporate features like low-flow fixtures, rainwater harvesting systems, and grey water recycling systems. Rainwater can be collected and used for irrigation or toilet flushing, while grey water wastewater from showers, sinks, and washing machines can be treated and reused for non-potable purposes. These strategies significantly reduce a building's reliance on municipal water supplies, which is especially important in water-scarce regions. A really interesting and visually striking green building technology is the rise of vertical gardens and green roofs. These aren't just for aesthetics, they provide tangible environmental benefits. Green roofs can reduce stormwater runoff, improve insulation, reducing heating and cooling costs, extend the life of the roof membrane, and create habitats for local wildlife. Vertical gardens or living walls can improve air quality, reduce the urban heat island effect by shading building surfaces and through evapotranspiration, and even provide a source of locally grown food in some cases. The overall design philosophy of green buildings also emphasizes passive design strategies. This means orienting the building to take advantage of natural light and ventilation, using high-performance windows and insulation to minimize heat loss or gain, and incorporating shading elements to reduce solar heat gain in warmer months. These passive measures can significantly reduce the need for active systems like artificial lighting and HVAC, further cutting down on energy consumption. It's about working with nature rather than against it. The push for green buildings is supported by various certification systems like LEED, Leadership in Energy and Environmental Design, and BREEAM, Building Research Establishment Environmental Assessment Method, which provide frameworks and benchmarks for sustainable construction. While there can be higher upfront costs associated with some green building technologies, the long-term savings in operational costs, coupled with the environmental benefits and improved occupant well-being, make it a compelling proposition for the cities of tomorrow. Chapter 5. Waste management innovations towards a circular economy. All right, let's tackle a less glamorous but incredibly important aspect of urban life: waste management. As urban populations grow, so does the sheer volume of waste they generate. Traditional landfill-centric approaches are unsustainable, polluting, and a waste of valuable resources. So future cities are adopting innovative technologies and strategies to manage waste more intelligently, aiming for a circular economy where waste is minimized and resources are recovered and reused. One of the foundational technologies here is the smart waste bin. These aren't your average trash cans. They're equipped with sensors that can detect fill levels, and sometimes even the type of waste. This data is transmitted wirelessly to a central management system, which can then optimize collection routes for sanitation trucks. Instead of trucks visiting every bin on a fixed schedule, regardless of whether it's full or empty, they can be dispatched only to bins that need servicing. This reduces fuel consumption, emissions, and operational costs for waste collection services. Beyond smarter collection, there's a huge focus on improving sorting and recycling. Advanced Material Recovery Facilities, MRFs, are using a combination of optical sorters, AI-powered robots, and sophisticated mechanical systems to separate different types of recyclables with much greater accuracy and efficiency than ever before. These robots can identify and pick out specific materials like different types of plastics, paper, and metals from a mixed waste stream at high speeds, significantly increasing recycling rates and the quality of recovered materials. Waste-to-energy, WT technologies, are also playing a crucial role, especially for non-recyclable waste. Instead of just burying this waste in landfills, WTE plants can convert it into usable energy, typically electricity or heat, through processes like incineration, gasification, or pyrolysis. Modern WTE plants are equipped with advanced emission control systems to minimize environmental impact. While not a perfect solution, as the ideal is to avoid waste generation in the first place, WTE can be a valuable tool for reducing landfill volume and recovering energy from what would otherwise be discarded. Promoting circular economy principles is key. This means designing products for durability and recyclability, encouraging reuse and repair, and developing new business models based on product as a service rather than outright ownership. Cities are fostering innovation hubs and supporting businesses that are developing circular solutions, whether it's turning organic waste into compost or biogas, or transforming plastic waste into new products like building materials or textiles. The goal is to keep resources in use for as long as possible, extracting maximum value and then recovering and regenerating products and materials at the end of their service life. Data analytics and public engagement are also vital. By tracking waste generation patterns, cities can identify hotspots and target specific interventions or awareness campaigns. Gamification and incentive programs can encourage citizens and businesses to reduce waste and recycle more effectively. Providing clear information on what can and cannot be recycled and making recycling convenient are simple but effective strategies. It's about creating a culture of resourcefulness and responsibility within the urban community. The transition to a truly circular waste management system is complex, requiring changes in consumer behavior, industrial processes, and policy. However, the environmental and economic benefits are compelling. Reducing landfill dependence, conserving natural resources, cutting greenhouse gas emissions, and creating new economic opportunities through resource recovery are all powerful motivators. Innovative waste management is no longer just about disposal, it's about resource stewardship in the urban age. So we've talked about buildings, energy, and waste. Now, let's look at something that might seem a bit unexpected in a dense urban environment: food production. Urban farming and vertical gardens are emerging as innovative ways to bring agriculture closer to consumers, reducing food miles, enhancing food security, and even greening the cityscape. It's about rethinking where and how our food is grown, especially in an increasingly urbanized world. Traditional agriculture often involves long supply chains, with food traveling hundreds or even thousands of miles from farm to table. This not only contributes to carbon emissions from transportation, but can also lead to food spoilage and nutrient loss. Urban farming aims to shorten these supply chains dramatically. This can take many forms, from community gardens in vacant lots and rooftop farms on top of buildings to more technologically advanced solutions like hydroponic or aquaponic systems housed in repurposed shipping containers or dedicated indoor facilities. Vertical farming is a particularly exciting development. This involves growing crops in stacked layers, often in controlled indoor environments. By precisely managing light, temperature, humidity, and nutrient delivery, vertical farms can produce high yields of crops like leafy greens, herbs, and small fruits year-round, regardless of external weather conditions. This method typically uses significantly less water and land compared to conventional agriculture and can eliminate the need for pesticides. It's like a high-tech, super-efficient greenhouse on steroids. These urban agriculture initiatives offer multiple benefits beyond just fresh produce. They can contribute to local food security, providing residents with access to nutritious food, especially in food deserts, urban areas where fresh, healthy food is scarce. They can also create local jobs and foster a greater connection between people and the food they eat. Community gardens, for instance, can become social hubs, bringing neighbors together and providing educational opportunities about sustainable food production. Integrating agriculture into the urban landscape can also have positive environmental effects. Green roofs and walls dedicated to food production can help reduce the urban heat island effect, improve air quality, and manage stormwater runoff, similar to ornamental green infrastructure. They add biodiversity to the city, creating habitats for pollinators like bees and butterflies. It's a way to make the city not just a consumer of resources, but also a producer in a green and sustainable way. The technologies enabling urban farming are constantly evolving. We're seeing advancements in LED lighting efficiency, automated climate control systems, AI-driven crop monitoring, and sophisticated hydroponic and aeroponic nutrient delivery systems. These innovations are making urban farming more economically viable and scalable. While it's unlikely that urban farms will replace all conventional agriculture, they can certainly supplement it, particularly for perishable, high-value crops. Challenges remain, of course, including the initial setup costs for high-tech systems, energy consumption for indoor farms, though this is improving with LED efficiency, and the need for skilled labor. However, as technology improves and cities increasingly prioritize local food systems and resilience, urban farming and vertical gardens are poised to become an increasingly important and visible feature of the cities of tomorrow. They represent a fusion of nature and technology right in the heart of our urban centers. All right, so we've discussed a lot of hardware and physical infrastructure. Now let's talk about the brains behind making it all work together seamlessly. Artificial intelligence, AI, and big data. In a smart city, the sheer volume of data generated by sensors, connected devices, public services, and even citizens themselves is immense. AI and big data analytics are the tools that allow cities to make sense of this data deluge, extract actionable insights, and optimize urban operations in ways that were previously unimaginable. One of the most impactful applications is in traffic management. AI algorithms can analyze real-time traffic flow data from cameras, road sensors, and GPS-enabled vehicles to predict congestion before it happens and dynamically adjust traffic signal timings to optimize flow. This can significantly reduce travel times, fuel consumption, and emissions. AI can also help plan public transport routes more effectively, adjusting schedules based on demand patterns and real-time conditions, ensuring that services are available when and where they are needed most. Emergency response is another critical area where AI and big data are making a difference. By analyzing data from various sources, emergency calls, social media feeds, sensor networks, AI can help identify incidents faster and more accurately, predict their potential impact, and optimize the dispatch of police, fire, and medical services. For example, AI can help predict wildfire spread or flood patterns, allowing for more targeted evacuations and resource deployment, ultimately saving lives and property. Resource allocation across the city can also be greatly enhanced. AI can analyze patterns of water and energy consumption to identify areas of high demand or potential wastage, helping utilities to manage resources more efficiently and plan infrastructure upgrades more effectively. In waste management, as we touched on, AI can optimize collection routes. In public health, AI can analyze health data to identify disease outbreaks early or predict areas at high risk for certain health issues, allowing for proactive interventions. Urban planning itself is being revolutionized. Traditionally, urban planning relied on historical data and manual analysis, which could be slow and sometimes outdated. Now, AI can process massive data sets encompassing demographic trends, land use patterns, environmental factors, economic activity, and public sentiment from social media, for example, to create sophisticated models and simulations. This allows planners to test different development scenarios, understand their potential impacts, and make more informed, data-driven decisions about how and where the city should grow. Of course, the use of AI and big data in cities raises important ethical considerations and challenges. Data privacy is a major concern. How is citizen data being collected, stored, used, and protected? There's also the risk of algorithmic bias, where AI systems trained on historical data might perpetuate or even amplify existing societal inequalities if not carefully designed and audited. Ensuring transparency, accountability, and fairness in the use of these powerful technologies is absolutely crucial for building trust and ensuring equitable outcomes. Ultimately, AI and big data are about transforming cities from collections of siloed systems into integrated, intelligent ecosystems. They provide the analytical power to understand complex urban dynamics and the predictive capabilities to manage them proactively. While the technology is a tool, its responsible and ethical application is key to unlocking its full potential to make cities safer, more efficient, more sustainable, and ultimately more livable for everyone. Finally, let's talk about one of the most fundamental resources for any city: water. As urban populations swell and climate change impacts water availability, efficient and sustainable water management is becoming increasingly critical. Future cities are leveraging a suite of technologies to monitor, conserve, and manage their water resources more effectively, ensuring that this precious liquid is available for all essential needs while minimizing waste and environmental impact. A key innovation is the rollout of the smart water meters. Similar to smart electricity meters, these devices provide real-time data on water consumption for both utilities and consumers. For utilities, this data helps in understanding demand patterns, identifying anomalies, and managing the distribution network more efficiently. For consumers, it offers a clear picture of their own usage, empowering them to make more informed decisions about conservation and potentially identify leaks on their property much sooner than with traditional monthly or quarterly readings. Leak detection is a massive area where technology is making inroads. A significant amount of water in urban systems is lost through leaks in aging pipes, sometimes as much as 20 to 30% or even more. Advanced leak detection systems use a variety of technologies, including acoustic sensors that listen for the sound of escaping water, pressure sensors that detect sudden drops, and even satellite imagery or AI algorithms that analyze flow data to pinpoint the location of leaks with remarkable accuracy. Proactively finding and fixing these leaks can save vast quantities of water and reduce the costs associated with water treatment and pumping. Grey water recycling and rainwater harvesting, which we touched on in green buildings, are also being implemented at a larger community or citywide scale. Centralized or decentralized grey water treatment systems can collect wastewater from showers, laundry and sinks, treat it and then redistribute it for non-potable uses like toilet flushing, irrigation of public parks and green spaces, or industrial processes. Similarly, large-scale rainwater harvesting projects, including permeable pavements and urban retention ponds, can capture stormwater, reducing runoff, replenishing groundwater, and providing an additional source of water. Advanced water treatment technologies are also crucial, especially in water-scarce regions. This includes processes like desalination, which converts seawater into fresh water, and advanced wastewater reclamation, which can treat sewage to a standard safe enough for drinking, often called direct or indirect potable reuse. While these technologies can be energy-intensive, ongoing research is focused on making them more efficient and cost-effective. They represent important tools for diversifying water sources and building resilience against drought. Data analytics and predictive modeling play a significant role here too. By integrating data from smart meters, weather forecasts, reservoir levels, and consumption patterns, AI-powered platforms can help water utilities predict demand, optimize reservoir operations, and manage drought conditions more effectively. They can also help in planning long-term infrastructure investments, ensuring that the water system can cope with future growth and climate variability. It's about using intelligence to make every drop count. The overarching goal of these water management technologies is to create a more circular and resilient urban water cycle. This means reducing reliance on single, often distant sources of fresh water, minimizing losses within the system, maximizing reuse and recycling, and ensuring that water quality is protected. Given that water is essential for life, public health, and economic activity, investing in smart water management is not just an option, but a necessity for the sustainable cities of the future. So, as we've seen, the technologies transforming our cities are incredibly diverse, touching almost every aspect of urban life. From the foundational smart infrastructure and IoT that act as the city's nervous system, to the AI and big data analytics providing the intelligence, the push is towards creating urban environments that are more efficient, responsive, and sustainable. It's a complex, interconnected web of innovations, all aimed at tackling some of the biggest challenges facing our rapidly urbanizing world. What's really exciting is that these technologies are not just futuristic concepts. They are being implemented today, paving the way for smarter, more sustainable cities. We're seeing pilot programs scale up, new policies being enacted to support these changes, and a growing understanding that investing in smart city tech is investing in our collective future. Of course, there are challenges: cost, equity, privacy, security, that need careful consideration and robust solutions. But the momentum is undeniable. The journey to the future city is an ongoing one, an evolution rather than an overnight revolution. It requires collaboration between governments, industry, academia, and most importantly, the citizens themselves. As these technologies continue to develop and integrate, the potential to enhance the quality of urban living, making our cities cleaner, greener, safer, and more engaging places to be, is truly immense. Stay tuned for more insights into the innovations that are shaping our world. Thanks for watching, and I'll catch you in the next one.